What if everything you thought you knew about life in the universe was just the beginning? Picture this, a night sky filled with countless stars, each one potentially hosting a world teeming with possibilities. For centuries, we've gazed up, imagining what lies beyond, wondering if we're truly alone. But what if the answer isn't light years away? It's waiting to be discovered on planets that could harbor life just like Earth. Today, we're taking you on an extraordinary journey through space to uncover 20 incredible planets that might just hold the key to this cosmic mystery. From rocky terrains bathed in alien sunlight to frozen moons hiding oceans deep beneath their icy crusts, each world on our list offers a unique glimpse into what life beyond Earth might look like. So stay with us as we explore these awe-inspiring destinations, all carefully chosen for their fascinating potential to support life. The universe is vast and full of secrets. Let's unveil some of them together. Now turning to the first planet on our journey, Proxima Centauri b. Located just a little over 4 light-years from Earth, this remarkable world orbits the star Proxima Centauri, the closest star to our Sun. What makes this planet so intriguing is its position within the habitable zone, a region around its star where conditions might allow liquid water to exist, a crucial ingredient for life as we know it. Proxima Centauri b is believed to have a rocky surface, much like Earth, which raises even more questions about its potential to support life. Imagine the possibility of alien oceans or perhaps even microbial ecosystems hidden beneath its surface. But this planet is not without its challenges. Its parent star, Proxima Centauri, is a red dwarf known for emitting intense stellar flares. These bursts of radiation could pose a threat to any atmosphere or surface conditions that might support life. Yet, scientists speculate that Proxima Centauri b might have a magnetic field strong enough to shield it from this radiation, similar to how Earth's magnetic field protects us from solar winds. Its proximity to us has made it a prime target for further exploration, with researchers eager to learn whether this nearby world could harbor the conditions necessary for life. Could Proxima Centauri b be a cosmic neighbor teeming with possibilities, or does its environment present insurmountable obstacles? Let us continue and explore the fascinating planets that follow on this incredible journey. As we delve deeper into Proxima Centauri b, the challenges faced by this distant world become even more apparent. The planet's orbit around Proxima Centauri places it precariously close to a red dwarf star notorious for intense stellar flares, powerful eruptions of energy and radiation that could strip away an atmosphere or drastically alter its surface conditions. For life to thrive, or even for liquid water to persist, such radiation would need to be countered. This is where the planet's potential magnetic field comes into play, sparking considerable scientific interest. If Proxima Centauri b does possess a magnetic field strong enough to shield its surface, it could act as a protective barrier, deflecting harmful radiation in much the same way Earth's magnetic field safeguards life here. This possibility not only raises questions about its atmospheric retention, but also about pathways for life to adapt and survive in such conditions. Adding to the intrigue is the fact that Proxima Centauri b is so close to our own solar system, making it a tantalizing candidate for future space missions and observational studies. With advanced telescopes and upcoming technology, scientists hope to gather more data about its atmosphere, surface composition, and habitability. The proximity of this planet makes these investigations feasible within the near future, offering a rare opportunity to explore a world that might just hold clues to the existence of life beyond Earth. Could Proxima Centauri b be a resilient haven where life has managed to emerge despite the odds, or do its challenges outweigh its potential? Moving forward, let us uncover the secrets of the planets that lie further along this thrilling quest for habitable worlds. Now turning to Kepler 452b, often referred to as Earth's cousin. This remarkable planet has captured the curiosity of scientists and space enthusiasts alike. Located over 1,400 light-years away in the constellation Cygnus, Kepler 452b shares striking similarities with our own planet. Its size is particularly notable as it measures only about 60% larger than Earth, placing it in the category of super-Earths. Even more compelling is its location within the habitable zone of its star, a region often called the Goldilocks zone, where conditions are just right for liquid water to exist on a planet's surface. What makes Kepler 452b even more fascinating is its parent star. This star is remarkably similar to our Sun in both size and temperature, offering a level of stability that could persist for billions of years. Such stability is critical for the development and sustainability of life, as it ensures a consistent energy source and favorable conditions over extended periods. Scientists believe that, given Kepler 452b's position and the longevity of its star, this planet may have had ample time to foster the chemical processes that could give rise to life. Additionally, its surface conditions, although still largely speculative, spark intriguing possibilities of an environment not unlike early Earth. With its similarities to our planet and the extended time frame provided by its Sun-like star, Kepler 452b serves as a valuable window into what Earth might look like in a different corner of the galaxy. Could this distant cousin harbor an ecosystem that evolved along a parallel path to our own, or has it taken a completely different trajectory? As we continue our exploration, Kepler 452b reminds us of the tantalizing potential for life beyond Earth and the endless possibilities that await our discovery. Moving forward, let us take a closer look at another intriguing world that challenges our understanding of habitability. As we delve deeper into the story of Kepler 452b, it becomes apparent why this planet is often seen as a glimpse into Earth's distant future. One of the most fascinating aspects of Kepler 452b is its age. This planet is estimated to be 1.5 billion years older than Earth. To put this into perspective, if Earth's timeline is a day, Kepler 452b's story would have started around 4 hours earlier. This extended lifespan under the steady glow of its Sun-like star offers a unique opportunity to understand how life could evolve over a significantly longer timescale. With an additional 1.5 billion years of potential chemical reactions and environmental shifts, the conditions on Kepler 452b might paint a picture of what Earth could become as its own star ages. This extra time could allow for more advanced biological processes or dramatically different ecosystems to develop, shaped by the subtle interplay of its environment and stellar energy. Scientists theorize that the extended age of Kepler 452b may have provided more opportunities for life to adapt and diversify, should the conditions for habitability have remained favorable. However, an older planet may also face challenges, such as a gradual cooling of its core or a potential loss of its magnetic field, which could expose its surface to increased radiation. These possibilities emphasize the delicate balance required for a world to sustain life over such vast timescales. By studying Kepler 452b's age and its implications, we not only expand our understanding of habitability, but also gain valuable insights into how the evolutionary trajectory of life might change in correlation with a planet's age and environmental dynamics. This celestial cousin not only enables us to look back at Earth's past, but also invites us to imagine the distant future of our own planet. Now, our exploration continues as we shift our gaze to an extraordinary planetary system that holds its own set of unique mysteries and possibilities. Now turning to the captivating TRAPPIST-1 system, we encounter TRAPPIST-1d, one of the 7 Earth-sized planets orbiting a faint, ultra-cool red dwarf star located just 40 light-years away. What makes TRAPPIST-1d stand out is its position within the star's habitable zone, the ideal distance where liquid water might exist on its surface. This tiny planetary system is a treasure trove for astronomers, as all 7 planets are packed closely together, giving scientists a rare opportunity to study a miniature version of a solar system in stunning detail. TRAPPIST-1d, in particular, captures attention because its size and rocky composition are strikingly similar to Earth's, suggesting that it could support conditions favorable for life. Scientists consider the discovery of this system groundbreaking because it provides strong evidence that Earth-sized planets are not only common, but may also form in configurations that allow for multiple potentially habitable worlds in close proximity. The faint glow of the TRAPPIST-1 star adds to the intrigue, as its relatively low energy output creates consistent and stable conditions compared to many other red dwarf stars, which are often prone to violent flares. This unique setup offers a laboratory for understanding how planets interact with one another and with their host star. The potential of TRAPPIST-1d to host liquid water, combined with the stability of its environment, makes it an exciting candidate in the search for extraterrestrial life. This discovery reminds us that even the faintest stars in the universe can harbor extraordinary possibilities, challenging our perceptions of where life might emerge. As we marvel at the secrets hidden in the TRAPPIST-1 system, let us now dive deeper into why this planetary family is considered a milestone in humanity's journey to uncover habitable worlds beyond our own. Moving forward, let's dive into what makes the TRAPPIST-1 system such a revolutionary discovery in the world of astronomy. What truly sets it apart is the extraordinarily tight arrangement of its 7 planets, all of which are Earth-sized. These planets are so closely packed that if you were standing on one, the neighboring planet might appear larger in the sky than our moon appears from Earth. This compact arrangement offers a unique window into planetary formation, as scientists can observe how these worlds interact gravitationally with one another and with their ultra-cool red dwarf star. The faint yet remarkably steady glow of TRAPPIST-1 star further enhances its significance. Unlike other red dwarf stars that often release violent flares, potentially harming any chance of habitability, this star maintains a quiet and consistent luminosity, which is ideal for creating stable environments over time. These qualities make the TRAPPIST-1 system a living laboratory for studying how habitable conditions might arise in scenarios vastly different from our own solar system. Another groundbreaking aspect is that 3 of these planets, including TRAPPIST-1d, fall squarely within the habitable zone where conditions may allow liquid water to persist. This raises an exciting possibility. Could multiple worlds in a single system simultaneously host life? The discovery of such a setup challenges traditional views of planetary habitability, expanding our understanding of where life might exist and thrive. By closely examining the TRAPPIST-1 system, astronomers hope to uncover clues not only about how planets form near faint stars, but also about how life-supporting conditions might develop elsewhere in the universe. As we contemplate these insights, we turn next to a planet that has earned the nickname Earth's cousin, a world that offers its own set of fascinating parallels to our home planet. Now turning to LHS 1140b, this intriguing super-Earth has captured the attention of scientists for its unique combination of density and location. Situated in the habitable zone of its star, LHS 1140b offers promising conditions that might support life. Its rocky composition, paired with an impressive density nearly 50% greater than Earth's, suggests that it could retain a substantial atmosphere. This is particularly critical as a thick atmosphere could help regulate surface temperatures and shield the planet from harmful radiation. One of the most exciting possibilities is the presence of liquid water, a key ingredient for life as we know it. LHS 1140b orbits a red dwarf star, but unlike some of its counterparts, this star exhibits relatively calm behavior, emitting fewer of the dangerous flares that could strip away a planet's atmosphere or disrupt its habitability. The planet's size, density, and position within the habitable zone make it a fascinating case for studying how rocky worlds might maintain the delicate balance needed for life to emerge. For researchers, LHS 1140b provides an extraordinary opportunity to examine the interplay between atmospheric retention, surface conditions, and potential habitability in ways that deepen our understanding of life hosting planets. As we marvel at this dense, rocky world, let's venture next to another captivating candidate, an Earth-like planet within a triple-star system that carries its own unique potential for sustaining life. Now turning to why LHS 1140b's density truly matters, it's important to understand how its exceptional mass and composition could play a pivotal role in its habitability. With a density 50% greater than Earth's, this super-Earth holds the potential to retain a thick and stable atmosphere. A denser planet exerts a stronger gravitational pull, which increases its ability to hold on to atmospheric gases, even in the face of solar winds and radiation. This retention is critical because a robust atmosphere can regulate surface temperatures, helping to create a more stable environment where liquid water could persist. The presence of such an atmosphere also offers vital protection from harmful cosmic radiation, shielding any potential life forms that might exist. Scientists speculate that this dense composition might have allowed LHS 1140b to maintain its atmospheric layers over long periods, increasing the chances for life to take hold. This also opens up possibilities for a dynamic climate system, potentially fostering conditions similar to Earth's. By studying a planet with such unique characteristics, researchers hope to uncover more about how rocky worlds can sustain life over time. As we explore the significance of density in preserving atmospheres, let's move ahead to an even more intriguing celestial candidate, Gliese 667cc. A fascinating planet nestled within a triple-star system that beckons us to imagine the possibilities for life in such a unique environment. Moving forward, let's focus on Gliese 667cc, an extraordinary planet located 23.6 light-years away in the constellation of Scorpius. What sets Gliese 667cc apart is its position within a triple-star system, a unique feature that immediately sparks curiosity about how life could adapt to such an environment. This rocky planet lies comfortably within the habitable zone of its primary star, a region where conditions are just right for liquid water to exist, a key factor in the search for life. Despite being slightly larger than Earth, Gliese 667cc shares striking similarities with our planet in terms of potential surface conditions. Scientists are particularly intrigued by the possibility of a stable climate, which could be supported by the planet's orbit around a relatively cool red dwarf star. This type of star emits steady light and less harmful radiation compared to more volatile stellar types, creating an environment that might allow life to flourish. Adding to its appeal, the gravitational interactions within the triple-star system could provide additional stability to the planet's orbit, enhancing its chances of sustaining life over long periods. Researchers even speculate about the visual phenomena potential life forms might experience. Imagine a sky graced by not one, but 3 stars. These stellar neighbors could contribute to a fascinating world with dynamic lighting and climate patterns. As Gliese 667cc continues to captivate the imagination of scientists and dreamers alike, it reminds us of the remarkable diversity in planetary systems. Now, as we move ahead from this celestial trio, let us explore another intriguing candidate that may hold clues to life beyond Earth, K218b, a planet where water vapor in the atmosphere has sparked renewed hope in our cosmic quest. Moving forward, let us turn our attention to K218b, a remarkable planet that has captured the interest of scientists due to a groundbreaking discovery: water vapor in its atmosphere. This singular finding has elevated K218b to the forefront of exoplanet research, as water vapor is one of the most essential ingredients for life as we know it. Located in its star's habitable zone, K2-18b orbits a relatively cool red dwarf, a combination that creates conditions potentially favorable for liquid water to exist on or beneath its surface. But what truly makes this planet intriguing is its unique classification. It is much larger than Earth, falling into a category often referred to as a mini Neptune. This larger size brings both promise and complexity when it comes to exploring its potential for life. Being a mini Neptune, K2-18b might possess a thick atmosphere filled with hydrogen and helium, which could obscure what lies beneath and pose challenges for supporting life in forms we are familiar with. Scientists speculate, however, that beneath this dense atmospheric layer, a temperate environment with liquid water could exist if conditions align just right. It is even possible that vast water-rich regions or even oceans might lie deep below, shielded from the thick gases above. While its larger size and atmospheric composition create obstacles for direct exploration or a clear understanding of its ability to host life, the detection of water vapor is a beacon of hope. This discovery has not only expanded our perspective on where to look for life, but has also raised questions about the diversity of conditions under which life might emerge in the universe. As we delve deeper into the mysteries of planets like K2-18b, we gain invaluable insights into the limitless possibilities of habitable worlds. Now, shifting gears to another fascinating prospect, let us explore Ross 128b, a planet just 11 light-years away that offers its own unique potential for supporting life. Now turning to Ross 128b, an intriguing Earth-sized planet that lies just 11 light-years away from us. What sets Ross 128b apart is the nature of its host star, a quiet red dwarf that provides a relatively stable environment with significantly less harmful radiation compared to other stars of its kind. This stellar activity plays a crucial role in enhancing the planet's potential habitability by allowing its surface and atmosphere, if it has one, to remain more stable over time. Scientists are particularly drawn to this planet because it resides within its star's habitable zone, the region where conditions might allow liquid water to exist. Its size, strikingly similar to Earth's, only deepens the excitement as this increases the likelihood of Ross 128b having a rocky composition, a key feature for potentially hosting life. Additionally, its close proximity to Earth makes it one of the more accessible exoplanets for future study, offering the tantalizing possibility of gathering more detailed data about its environment. Observations so far do not indicate extreme conditions that would rule out the formation of life, although much remains to be learned about its atmosphere, climate, and surface features. The quiet nature of its star and its location in the habitable zone make Ross 128b a prime candidate for continued exploration and one of the most promising nearby exoplanets in the search for life beyond Earth. As we look deeper into the endless possibilities of habitability across the stars, let us now turn our attention to another fascinating world within reach, the super-Earth known as Wolf 1061c. Moving forward, we arrive at Wolf 1061c, a captivating super-Earth situated just 14 light-years away. This planet orbits within the habitable zone of its star system, a region where the temperatures might be just right to support liquid water, a critical ingredient for life as we know it. What makes Wolf 1061c particularly intriguing is its unique position within this zone. Being on the inner edge of the habitable zone means it might experience temperatures slightly warmer than Earth's, potentially creating a range of climates across its surface. This opens up fascinating possibilities. Certain regions could be hot and arid while others might sustain more temperate conditions. Scientists believe that if liquid water does exist here, it could gather in specific areas, such as cooler regions or pockets of the surface shielded from excessive heat. Wolf 1061c is also significantly larger than Earth, a factor that could influence its gravity, atmosphere, and surface dynamics. Greater gravity might help retain a thicker atmosphere, which could in turn regulate and moderate its surface temperatures. However, many questions remain unanswered, particularly about the composition of its atmosphere, if it has one, and how this might affect its potential for habitability. While these uncertainties leave room for speculation, Wolf 1061c stands out as a prime subject for further study. Its relative proximity to Earth makes it an exciting target for future missions and research that could reveal more about its environment. Could this super-Earth be a world where life might thrive, or does its close position to the heat of its star pose challenges too great to overcome? With Wolf 1061c sparking these questions, the journey through potential life-supporting planets continues as we now turn to Tau Ceti, a planet orbiting one of the closest Sun-like stars to Earth. Now turning to Tau Ceti, this fascinating exoplanet orbits a star remarkably similar to our Sun, located just 12 light-years away. Tau Ceti is often highlighted in discussions about potential habitability due to its position on the inner edge of its star's habitable zone. This means it likely experiences temperatures that lean toward the warmer spectrum, possibly making it hotter than Earth. Its larger size compared to our home planet also adds an interesting dimension to its potential for life. A bigger planet could mean stronger gravity, which might allow it to hold onto a denser atmosphere. Such an atmosphere could help moderate surface temperatures and create a shield against harmful cosmic radiation, both of which are essential for sustaining life. However, the warmer positioning of Tau Ceti within the habitable zone brings questions about its surface conditions. Could it resemble a drier, desert-like landscape, or might certain areas retain enough cooler climates to support liquid water? Additionally, the star it orbits is older than our Sun, a factor that could influence the planet's environment over time. An aging star might emit less energy, potentially allowing the planet's surface to stabilize after prolonged exposure to higher temperatures in its earlier history. This balance between heat and habitability makes Tau Ceti a compelling subject for astronomers who are eager to uncover whether its conditions could support life. Despite these questions, the close proximity and Sun-like qualities of its star make Tau Ceti an exciting candidate for future exploration. As we ponder what mysteries it might hold, the journey continues with yet another intriguing prospect, HD 40307G, a planet nestled within the Goldilocks zone of its star system. Now turning to HD 40307G, this super-Earth offers yet another thrilling possibility in the search for habitable worlds. Located in the Goldilocks zone of its star system, HD 40307G finds itself at just the right distance to potentially support liquid water, a crucial ingredient for life as we know it. What makes this planet particularly fascinating is its size, which is several times larger than Earth. While its greater mass likely means stronger gravity, this could allow it to retain a thicker atmosphere, contributing to a stable climate over time. Scientists speculate that such an atmosphere might help regulate surface temperatures, creating conditions that could be more hospitable for life. Moreover, its orbit around a quiet star adds to its allure. Unlike more volatile stars that bombard nearby planets with harmful radiation, HD 40307G star seems to provide a relatively calm environment, increasing the chances for a thriving ecosystem. With its position in the habitable zone and its potential for liquid water, this planet invites the tantalizing question: what might lie beneath its surface or within its atmosphere? Could it harbor vast oceans or perhaps support life forms adapted to conditions unlike anything we've encountered before? These possibilities make HD 40307G a compelling target for future space missions, where advanced instruments could help us unlock its secrets. As we contemplate this intriguing world, the journey doesn't end here. Up next is Captain B, a planet orbiting a stellar system that's not only Earth-like but also astonishingly ancient, twice as old as our Sun. Now turning to Captain B, this remarkable planet captures attention not only for its Earth-like qualities but also for its sheer age. Orbiting a stellar system that is twice as old as our Sun, Captain B challenges many of our assumptions about what makes a planet habitable. Being this ancient, it offers a unique glimpse into the possibilities of life evolving over an extraordinary timeline. Its rocky composition and location within the habitable zone raise intriguing questions about whether it could support liquid water, a cornerstone for life as we understand it. What's even more fascinating is how its extended history might have influenced the planet's environment and the potential for life forms to adapt to its conditions. With billions of additional years compared to Earth, could Captain B harbor ecosystems that have reached levels of complexity we can hardly imagine? The planet's proximity to its red dwarf star provides another layer of intrigue. This star allows the planet to remain within a promising temperature range for sustaining life while offering a stable environment over the eons, despite the challenges of its age, such as potential atmospheric loss or surface wear. Its resilience makes it a highly compelling subject for study. Could Captain B be a time capsule of sorts, holding clues to the origins and endurance of life in the universe? As we ponder its ancient mysteries, our journey continues to an equally exciting destination. Up next is TOI 700d, an extraordinary planet discovered through groundbreaking work by NASA TESS mission, offering yet another glimpse into the boundless possibilities that lie beyond our own world. Now turning to TOI 700d, this Earth-sized planet stands out as a beacon of hope in the search for habitable worlds. Discovered through the innovative efforts of NASA, a transiting exoplanet survey satellite, TOI 700d resides within the habitable zone of its star, where conditions could allow liquid water to exist. This detail alone sparks immense excitement, as water is fundamental in our understanding of life's building blocks. What makes TOI 700d even more intriguing is its size and composition, both of which closely resemble Earth, raising exciting possibilities about its surface conditions. Could it host an atmosphere capable of supporting life? Scientists are exploring this very question, given the planet's unique position around a small red dwarf star. This type of star tends to have a much longer lifespan than our Sun, potentially offering TOI 700d a stable environment for billions of years' time that could be crucial for life to emerge and evolve. And while red dwarf stars are often known for their intense flares, this particular star appears relatively calm, enhancing the planet's chances of maintaining habitability. Furthermore, its location at just over 100 light-years away means it's within reach of detailed observations from advanced telescopes. These tools may soon unlock clues about its atmospheric composition and whether conditions truly align with what we associate with life. TOI 700d has fast become a focus of scientific curiosity, showcasing how far we've come in identifying not just planets, but worlds that seem to mirror our own in unimaginable ways. As this remarkable discovery drives us to imagine the possibilities, our next stop takes us to a planet steeped in mystery, 55 Cancri F, where the potential for hosting life takes an unconventional turn. Now turning to 55 Cancri F, this fascinating planet lies in a solar system not too far from our own, captivating scientists with its unique allure. While it sits just beyond the conventional boundaries of the habitable zone, the possibility of life cannot be easily discounted. Its position suggests that conditions on the planet itself might not entirely support life as we know it, but the story does not end there. Scientists speculate that 55 Cancri F could host moons or regions along its outer edges where the right combination of factors might create pockets of habitability. Imagine an environment where tidal heating, a process generated by gravitational interactions with its parent star or neighboring planets, could warm these areas enough to sustain liquid water. This phenomenon draws comparisons to moons like Europa in our own solar system, where internal heat potentially sustains subsurface oceans despite being far from the sun's warmth. Additionally, its parent star, known as 55 Cancri A, is remarkably similar to our Sun in terms of size and brightness, which fuels hope that this system might harbor more secrets waiting to be uncovered. The planet's larger size, often compared to that of a mini Neptune, also sparks curiosity about its atmospheric composition and whether it might contain elements necessary for life in unexpected forms. Advanced telescopes are only beginning to scratch the surface, with future observations expected to shed light on just how this intriguing world fits into the broader puzzle of potentially habitable environments. As we ponder the mysteries surrounding 55 Cancri F, prepare to delve into another extraordinary destination, TRAPPIST-1e, a planet that redefines what it means to be Earth-like. Now turning to TRAPPIST-1e, this gem within the TRAPPIST-1 system has captured the imagination of scientists and space enthusiasts alike. Out of the 7 Earth-sized planets orbiting this ultra-cool dwarf star, TRAPPIST-1e stands out as a particularly promising candidate for habitability. What makes it so special? To begin with, its location in the habitable zone positions it at an optimal distance from its star, potentially allowing for surface temperatures where liquid water could exist, a critical ingredient for life as we know it. Unlike its siblings, TRAPPIST-1e boasts a density strikingly similar to Earth's, indicating a rocky composition that could support solid ground, unlike gaseous worlds or planets with thick, uninhabitable atmospheres. Further adding to its allure, the star it orbits is both cooler and much smaller than our Sun, emitting just a fraction of the harmful radiation that could threaten a planet's atmosphere or any potential life forms. This faint, steady glow from the TRAPPIST-1 star means that conditions on TRAPPIST-1e might remain stable over long periods, providing an opportunity for life to evolve. In addition, the closeness of the 7 planets in this system offers an unprecedented opportunity for exploration. Standing on TRAPPIST-1e, one could hypothetically see its neighboring planets as bright objects in the sky, a surreal connection between worlds that fuels endless speculation about what interplanetary dynamics might look like here. With its many Earth-like qualities, TRAPPIST-1e has become a key focus for astronomers using powerful tools like the James Webb Space Telescope to study whether its atmosphere could sustain life. The hope is that upcoming observations will soon reveal whether this extraordinary planet might be one step closer to uncovering life beyond Earth. As we marvel at the possibilities of TRAPPIST-1e, let's take a closer look at the next captivating world in our journey, YZ Ceti b, a rocky exoplanet offering its own unique promise. Now turning to YZ Ceti b, this intriguing rocky exoplanet orbits a quiet red dwarf star located just a few light years away from Earth. What sets it apart from many other exoplanets is the relatively calm nature of its host star. Unlike other red dwarfs that often bombard their planets with intense stellar flares and harmful radiation, YZ Ceti's moderate stellar activity creates a more stable environment, increasing the likelihood that this planet could sustain conditions suitable for life. Its position within the habitable zone of its star further enhances its promise, offering the possibility of liquid water on its surface, a cornerstone for the development of life as we understand it. While YZ Ceti b's exact atmospheric composition is still a mystery, the planet's rocky structure hints at the potential for a solid surface, which is essential for supporting complex life forms. Moreover, the star's cooler and dimmer nature compared to our Sun means that YZ Ceti b could maintain a more temperate climate, shielding it from the extreme temperature fluctuations often faced by planets orbiting hotter stars. These unique characteristics make YZ Ceti b a fascinating target for ongoing research, as astronomers continue to explore its potential for habitability with advanced observational techniques. With each new discovery, this quiet yet captivating exoplanet reminds us how the universe is filled with diverse worlds that defy expectations. As we leave YZ Ceti b behind, let us journey to the next remarkable destination in our cosmic exploration, the potential water world of GJ 1214b. Now turning to GJ 1214b, this intriguing exoplanet offers a unique glimpse into what a water world beyond Earth might look like. Located approximately 40 Earth years away, GJ 1214b is classified as a mini-Neptune, meaning it is larger than Earth but smaller than the gas giants in our solar system. One of the most fascinating aspects of this planet is its thick atmosphere, which scientists believe could be primarily composed of water vapor. Beneath this dense layer of clouds, it is speculated that a vast ocean may exist covering the entire surface of the planet. If true, this could create an environment unlike anything we've seen before, potentially harboring conditions conducive to simple forms of life. The atmospheric pressure and lack of a solid landmass, however, might present challenges for the kind of complex ecosystems we are familiar with. Unlike Earth, where the interaction between land and sea plays a crucial role in climate and biodiversity, a fully oceanic world like GJ 1214b may rely entirely on its atmosphere and thermal activity to sustain any potential biosphere. Despite these uncertainties, the idea of life thriving in such an environment isn't as far-fetched as it seems. On Earth, deep-sea hydrothermal vents teem with organisms that survive without sunlight, relying instead on chemical energy from the planet's interior. A similar process could theoretically occur on GJ 1214b, with life forms evolving to adapt to the unique conditions of a world dominated by water and gas. The planet's relatively close proximity also makes it an excellent candidate for atmospheric studies using advanced telescopes like the James Webb Space Telescope. These explorations could help unlock the secrets of this mysterious world, providing valuable insights into how diverse planetary environments can be and expanding our understanding of where life may exist beyond our solar system. With GJ 1214b's mysteries in mind, let us set our sights on the next celestial body, Europa, a moon of Jupiter that hides an ocean beneath its icy crust. Now turning to Europa, one of Jupiter's most captivating moons, this celestial body stands out as a prime candidate for supporting life in our solar system. Beneath its thick, icy crust lies a vast subsurface ocean, which scientists believe holds more water than all of Earth's oceans combined. This hidden ocean is kept in a liquid state thanks to tidal heating, a process where gravitational forces from Jupiter and its neighboring moons generate internal friction, producing enough heat to prevent the water from freezing solid. Such a dynamic environment makes Europa an incredibly intriguing target in the search for extraterrestrial life. On Earth, we have discovered microbial life thriving in extreme conditions, from the icy depths of Antarctica to hydrothermal vents on the ocean floor, proving that life can exist in places devoid of sunlight and subject to extreme pressures. Europa's ocean, shielded from radiation by its icy shell, could harbor similar microbial ecosystems. Nutrients and energy sources could be supplied by hydrothermal vents on the ocean floor or interactions between the surface ice and the liquid water below. Beyond the promise of microbial life, Europa has also inspired the tantalizing possibility of more complex organisms evolving in its unique environment, though such scenarios remain speculative. Europa's potential for habitability has made it a focal point for upcoming missions, such as the Europa Clipper, set to launch in the coming years. This mission aims to study Europa's surface, measure the thickness of its ice crust, and assess its subsurface ocean's composition and habitability. If evidence of even the simplest life forms is found, it could revolutionize our understanding of biology and the conditions necessary for life to emerge. With the mysteries of Europa stirring the imagination, let us now shift our gaze to another icy world with extraordinary potential, Enceladus, one of Saturn's most fascinating moons. Now turning to Enceladus, one of Saturn's most intriguing moons, this icy world has captured the imagination of scientists and space enthusiasts alike. What sets Enceladus apart is its remarkable geysers, which erupt from cracks in its icy surface, sending plumes of water vapor, ice particles, and organic compounds into space. These geysers, discovered by the Cassini spacecraft, provide direct evidence of a subsurface ocean beneath the moon's frozen crust. This ocean, kept liquid by heat generated through tidal forces from Saturn, is a potential habitat for life. The presence of organic materials in the plumes further raises the possibility that Enceladus Ocean contains the building blocks of life. Scientists have speculated that hydrothermal activity on the ocean floor could provide the necessary energy and nutrients to support microbial ecosystems, similar to those found near deep-sea vents on Earth. These vents are teeming with life despite the lack of sunlight, suggesting that a similar process could occur on Enceladus. The simplicity of potential microbial life is compelling, but it also sparks curiosity about whether more advanced life forms could theoretically exist in such an environment. Future missions are being proposed to fly through these geysers and directly sample the ejected material for signs of life. Enceladus offers the unique advantage of allowing scientists to study its subsurface ocean without needing to drill through its icy crust, making it one of the most accessible targets in the search for extraterrestrial life. As we continue to push the boundaries of exploration, Enceladus reminds us of the extraordinary potential for life in places we once thought impossible. With Enceladus' fascinating features fresh in our minds, let us now venture further to explore another moon of Saturn, the enigmatic Titan, with its thick atmosphere and liquid methane lakes. Now turning to Titan, Saturn's largest moon and one of the most intriguing bodies in our solar system, this alien world captivates scientists with its unique and otherworldly characteristics. Titan boasts a thick, nitrogen-rich atmosphere, the only one of its kind among the moons in our solar system, which creates a dense orange haze around the surface. Beneath this atmospheric shroud, Titan reveals another astonishing feature: vast lakes and rivers of liquid methane and ethane, forming a hydrological cycle unlike anything found on Earth. These liquid hydrocarbons flow and evaporate, mimicking the water cycle we are familiar with, but in a composition that would be deadly to life as we know it. However, this stark contrast to our planet is precisely what makes Titan so fascinating. Scientists speculate that life forms, if they exist here, would have to be radically different, relying on methane rather than water as a solvent for biological processes. This has led researchers to redefine their understanding of the conditions necessary for life. Titan's surface may also conceal water-based reservoirs beneath its ice shell, creating a dual environment for exploration, one on the surface with its extreme cold and methane lakes, and another potentially more Earth-like under its icy crust. Such possibilities make Titan a prime target for future missions aimed at discovering alien life. Upcoming explorations like the Dragonfly mission are designed to study its complex chemistry and search for signs of probiotic activity or even life itself. Titan challenges our fundamental assumptions about habitability and invites us to consider the unimaginable, life thriving in environments that on Earth would be inconceivable. As we ponder the mysteries of this captivating moon, let us now journey to the most familiar candidate in our search for life beyond Earth, the enigmatic red planet Mars. Now turning to Mars, the red planet has long captured humanity's imagination as our closest and most thoroughly studied candidate for hosting life beyond Earth. Mars presents a landscape both barren and breathtaking, dotted with ancient riverbeds, vast canyons, and towering volcanoes. One of its most compelling features is evidence of its watery past. Billions of years ago, Mars likely had flowing rivers, lakes, and possibly even oceans, suggesting a time when it may have been hospitable to primitive life forms. Today, traces of this liquid water remain frozen in its polar ice caps and underground reservoirs, sparking scientific curiosity about its potential to support microbial life. However, Mars presents significant challenges to habitability. Its thin atmosphere, composed primarily of carbon dioxide, offers little protection against harsh solar radiation and results in surface conditions that are cold and dry. Despite this, the discovery of recurring slope-line streaks that appear seasonally and may indicate briny liquid water further deepens the intrigue. Scientists are also drawn to Mars because of its geological diversity, which provides clues about the planet's history and evolution. Upcoming missions like ExoMars and continued efforts by the Perseverance rover aim to collect rock and soil samples in search of biosignatures or chemical indicators of past or present life. These explorations are complemented by plans to establish human settlements on Mars in the future, with Mars viewed not only as a window to discover extraterrestrial life, but also as a potential second home for humanity. As we continue to uncover the mysteries of this iconic red planet, its secrets may ultimately redefine our understanding of life and our place in the universe. With Mars explored as our familiar frontier, let us now dive deeper into the broader question of whether life beyond Earth could take forms we have yet to imagine. As the next chapter unfolds, we are faced with a fascinating question. Could life beyond Earth take forms that defy everything we know? This is where planets like Titan, Saturn's largest moon, urge us to rethink the fundamental requirements for life. While Earth's biosphere thrives on water as the foundation of life, Titan presents an entirely different paradigm. Here, lakes and rivers of liquid methane and ethane carve through its surface, and temperatures plunge to extremes that would be uninhabitable by terrestrial standards. Yet, scientists speculate that life forms could exist in such an environment, relying on liquid methane as a solvent instead of water. This challenges our understanding of biochemistry and expands the possibilities of what life could look like. Imagine organisms breathing not oxygen but hydrogen, and incorporating methane into their cell structures instead of water. Such life forms, while hypothetical, show how nature might adapt to conditions wildly different from those on Earth. But Titan is just one example. Other celestial bodies like Europa with its subsurface ocean or Enceladus with its geysers of organic material remind us that life might not require surface water or even sunlight. Extremophiles on Earth, organisms found in boiling hot springs, under crushing ocean pressure, or inside rocks deep underground prove that life can survive in seemingly impossible conditions. If life can adapt to Earth's harshest environments, could it not also evolve in diverse and unexpected ways elsewhere in the cosmos? This thought shifts the focus from searching for Earth-like planets to considering worlds that are utterly alien. It invites us to explore how chemistry, physics, and biology might interact under conditions so extreme they barely seem imaginable. This broader perspective not only fuels our curiosity, but also opens a world of possibilities for where we search and what we might find. As our understanding expands, so too does the potential for discoveries that could redefine life itself and our place in it. With this intriguing idea of unorthodox life forms in mind, let us now delve into the role of technology in unraveling these mysteries and identifying new worlds teeming with potential. With the next phase of the journey in sight, we turn our attention to the incredible tools that make the search for new worlds possible. Technology has been the silent explorer, venturing far beyond what human eyes can see and uncovering secrets of the cosmos. One of the most groundbreaking advancements in this quest is the James Webb Space Telescope. This marvel of engineering allows scientists to peer deeper into space than ever before, capturing light from distant exoplanets and analyzing their atmospheres for signs of habitability. By using a technique called spectroscopy, It can detect the chemical fingerprints of elements like water vapor, carbon dioxide, and even potential biosignatures, elements that may hint at the presence of life. The telescope's sensitivity to infrared light also enables it to study planets that orbit faint, cool stars, opening up a wider range of potential candidates for habitability. Yet the James Webb Space Telescope is just the beginning. The upcoming Roman Space Telescope promises to take this exploration even further. Designed to conduct wide-field surveys, it will identify thousands of exoplanets with stunning precision, including those smaller and closer to Earth's size. Its ability to observe the minute dimming of a star's light caused by a planet passing in front of it, known as the transit method, will expand our catalogue of planets and provide valuable data on their compositions and environments. Together, these telescopes work as complementary tools, each offering unique capabilities that bridge the gaps in our understanding. But it's not just about finding planets, it's about characterizing them. Advanced instruments are now capable of detecting planetary climates, surface conditions, and even the presence of clouds or oceans. For instance, spectrometers on these telescopes can analyze the light passing through a planet's atmosphere during a transit, revealing crucial details about its chemical makeup. These insights help scientists determine whether a planet could support life as we know it or inspire new theories about life in forms we have yet to imagine. Ground-based observatories also play a vital role in this endeavor. Facilities with adaptive optics now reduce the distortion caused by Earth's atmosphere, enabling sharper images of distant worlds. Collaborations between space and ground-based telescopes allow for cross-validation of discoveries, ensuring robust and reliable results. Meanwhile, artificial intelligence is revolutionizing the way data is processed, helping researchers sift through the vast amounts of information collected to identify promising candidates more efficiently. As technology continues to evolve, so does our capacity to answer some of the universe's most profound questions. These advancements not only push the boundaries of what we can see, but also challenge us to reconsider the very nature of life and its potential to thrive in environments far different from Earth. With each new discovery, we come one step closer to unlocking the mysteries of the cosmos, fueled by the tools that turn human curiosity into tangible exploration. As we marvel at the power of technology, let us now explore how these remarkable findings inspire future missions aimed at bringing us even closer to unraveling the enigma of life beyond Earth. Moving forward, the discoveries of these planets serve as a powerful motivation for ambitious future missions that promise to bring us closer than ever to answering the age-old question, are we alone in the universe? One such mission, the Transiting Exoplanet Survey Satellite, or TESS, has already proven its value by identifying hundreds of exoplanets with potential for habitability. By scanning vast portions of the sky, TESS focuses on nearby stars, providing scientists with a treasure trove of planets that are not only exciting but also relatively accessible for further study. Its mission is far from over, and as it continues to expand our knowledge, it lays the groundwork for more detailed investigations by advanced telescopes. Another groundbreaking mission taking the spotlight is the Europa Clipper. This spacecraft is set to explore one of the most intriguing places in our solar system, Jupiter's icy moon, Europa. With a massive subsurface ocean hidden beneath its frozen crust, Europa has long captivated scientists as a potential haven for alien life. The Clipper will analyze its icy surface, measure the moon's magnetic field, and search for signs of liquid water and organic material. These findings could redefine our understanding of where life might exist beyond Earth, providing clues about the conditions necessary for its emergence. And let's not forget about the James Webb Space Telescope, which doesn't just look at distant exoplanets but also examines worlds within our own celestial neighborhood. By providing unparalleled detail, it complements other missions like TESS and Europa Clipper with its ability to analyze the atmospheres of planets, looking for chemical traces that could indicate microbial or even more complex forms of life. Meanwhile, upcoming projects like the Dragonfly mission aim to explore Saturn's moon Titan, a world so alien yet so fascinating with its lakes of liquid methane and thick atmosphere. Dragonfly will provide essential data that could help us understand life in environments vastly different from Earth's. The synergy between these missions is where the true magic happens. Each one builds on the discoveries of its predecessors, forming a chain of exploration and understanding that pushes us closer to the answers we seek. Data collected from TESS informs the targets for follow-up studies by the James Webb Space Telescope. Similarly, Europa Clipper's exploration could inspire new missions to other moons like Enceladus, where water geysers erupt into space. This collaborative approach across multiple missions and technologies ensures no stone is left unturned in the search for life. As humanity reaches out into the cosmos, each of these missions represents more than scientific discovery. They symbolize human curiosity, ingenuity, and our unwavering desire to explore the unknown. With every kilometer traveled, every star surveyed, and every planet probed, we find inspiration not only to uncover what's out there, but also to understand our own place in the universe. Now, as we reflect on these missions and what they mean for our quest to find extraterrestrial life, let us take a moment to think about how the existence of alien life might transform our perspective of the cosmos and ourselves. As we conclude our journey through these incredible 20 worlds, each one stands as a beacon of possibility in our vast universe. From the nearby Proxima Centauri b to the distant Kepler 452b, each planet, moon, or celestial body offers glimpses into environments that could potentially harbor life. Some, like Europa and Enceladus, hold vast oceans beneath their icy surfaces, while others, like TRAPPIST-1e and LHS 1140b, shine as rocky planets in the habitable zones of their stars, resembling Earth in ways that awaken our deepest curiosities. These places not only expand our understanding of where life might arise, but challenge us to rethink life itself. Could it exist in forms we've never imagined, thriving in conditions far beyond what we know? And as we reflect on all this, the question grows ever more compelling. Could one of these worlds harbor our cosmic neighbors, intelligent beings, or even the simplest forms of life waiting to be discovered? Such a discovery would not only reshape science, but also our understanding of ourselves and our place in the universe. The search for life beyond Earth is more than a scientific endeavor. It's a quest that unites and defines us as a species, driven by the desire to explore, to learn, and to connect with something greater. As we continue to unravel these cosmic mysteries, we invite you to share your thoughts. Which of these worlds do you think holds the most promise? What excites you most about the search for alien life? Let us know in the comments below. Don't forget to like this video, subscribe to our channel, and hit the notification bell so you never miss an update as we venture deeper into the stars. The cosmos is vast and full of wonder, and together we'll continue exploring its endless horizons. Thank you for joining us, and we'll see you in the next adventure.